Imagine a world of near-instant communication, where holographic displays and massive IoT networks are the norm. This is the promise of 6G. But beneath this seamless connectivity lies a powerhouse of mathematics. At the heart of 6G is the ability to solve massive linear systems in real time. In engineering, we represent these complex interactions as linear systems. AX equals B. In 6G, these aren't just equations, they are the signals themselves. Take beamforming, for example. To focus a signal directly on your device among millions, we solve for the exact phase and amplitude using matrix operations. With 6G, the scale is unprecedented. We are talking about matrices with thousands of variables that must be solved in microseconds. Traditionally, we've relied on exact methods like Gaussian elimination or Gauss-Jordan to find the perfect solution. But exact methods have a cost. For massive arrays, the computational complexity grows cubically, hitting a wall when speed is critical. Matrix inversion is another cornerstone. Finding the inverse allows us to isolate our unknowns directly, but it requires the matrix to be non-singular. To save time, we often use LU decomposition, factoring a matrix into two simpler parts. It's like breaking a complex signal into manageable waves. In the real world of 6G, signals are never perfect. Interference and noise create systems that are highly sensitive, what we call ill-conditioned. We measure this sensitivity using norms, a way to quantify the size or magnitude of our vectors and matrices. The condition number tells us if our solution is reliable. In 6G channel estimation, a high condition number means a small error in signal leads to a total loss of data. This is where iterative methods shine. Instead of one long, heavy calculation, we approach the solution step by step. Methods like Jacobi and Gauss-Seidel are the workhorses of real-time signal processing, refining our estimates until the error is negligible. Speed is everything. Iterative methods allow 6G systems to adapt to changing environments in the blink of an eye. When we have more equations than unknowns, a common scenario in noisy environments, we use the least squares method to find the most probable truth. By transforming our system into the normal equation, we minimize the error vector, ensuring 6G signals remain crisp and clear. Mastering these concepts is how you will build the next generation of connectivity. Linear algebra isn't just math, it's the foundation of 6G. In the massive world of 6G, the scale is everything. We aren't just solving for one user, but for billions of connected devices simultaneously. In the 6G era, computational efficiency is as important as signal power. Every operation saved is a bit more bandwidth for the user. Robustness is key. Our linear solvers must handle the chaotic fluctuations of high-frequency signals in any environment. As we move into sub-terahertz frequencies, the precision required in our linear systems reaches an atomic level. Real-time channel estimation is like solving a puzzle where the pieces are moving at the speed of light. Matrix methods are the solver. By tuning parameters in successive relaxation, we can accelerate convergence, getting to the right answer faster than ever before. But beware of singularity. If our matrices lose their rank, the system becomes a dead end. Identifying these early is critical for reliable networks. Always remember the geometry. Every linear system is just a set of planes in space, and our goal is to find where they all meet. For a third-year engineer, these aren't just homework problems. They are the tools you'll use to solve the world's most complex challenges. From smart cities to autonomous vehicles, every node in the 6G network is a variable in a massive global linear system. We leverage parallel processing to solve these systems, distributing the workload across thousands of cores to keep the 6G dream alive. Whether it's the Euclidean norm or the infinity norm, choosing the right measure of magnitude ensures our algorithms are precise and stable. 6G will also integrate AI directly into the network edge, using these very linear methods to train models in real time. In the end, it all comes down to convergence, bringing disparate signals together into a coherent, powerful stream of information. Gaussian elimination, LU decomposition, iterative solvers. These are the tools in your belt. Use them wisely to build the future. As we look beyond 6G, the systems will only get larger. The foundations you learn today are the bridge to what comes next. Even in the noisiest channels, a well-conditioned system finds the path. This is the art of engineering. Mathematics is the universal language of connectivity. It's how we bridge the gap between people and machines. Precision in matrix inversion is the difference between a successful 6G handshake and a dropped connection. Every decimal place matters. The 6G era is coming, and it will be defined by the engineers who mastered the math of systems. Will you be one of them? Remember the determinant. It's the gatekeeper of your system, the single value that tells you if a solution even exists. Whether you stop at the upper triangle or go all the way to the identity matrix, efficiency is your ultimate guide. LU decomposition is a dance of forward and backward substitution. It's a method of elegance and computational speed. Data isn't just numbers. It has a magnitude. Norms allow us to see the length of our information in the digital void. The world is messy. A stable system can weather any storm. That is the goal of every 6G engineer. Iteration is the art of getting closer. Each cycle brings us one step closer to the perfect 6G solution. In the face of uncertainty, we find the best fit. Least squares is our bridge across the noise. The normal equation is your guide. It simplifies the chaos, turning an overdetermined mess into a solvable reality. This is the big picture. Your work on these linear systems is what will connect the entire world in the 6G era. Your journey through engineering is just beginning. These concepts are your foundation. Build something incredible. Never underestimate the power of math. It is the engine of the future. It is the core of 6G. Go forth and engineer. The 6G future is in your hands.